Hello everyone. I'm attempting to repair a Viewsonic 65-inch Viewboard that I got for free because it was no longer working. The backlight was not working, and other technicians were not able to get it repaired. So I'm going to make an attempt on it. I just want to say that this is a dangerous procedure. There's high voltage, and 400 volts. So one mistake could be a very disastrous thing. So please be careful and don't attempt this unless you have a safe capacitor discharge tool and knowledge on how to be safe while working on high voltage electronics. All right, so this is the Viewboard PSU, and it has 120 volts coming in here. I pulled this out of the TV so that I can power it up. This is just um, the plug-in board that is on the TV, and I can just plug it in there to get the 120 volts. And I should mention that I have this on an isolated power supply, so the neutral is not connected to the building ground. So I can plug the oscilloscope in here anywhere basically, and not have a flash and destroy my oscilloscope or components on the board. So the 120 comes in here, goes through some fuses and through some inductors, MOSFETs, and charges your main capacitors here. These main capacitors charge up to 400 volts, and they are quite scary. Once they're charged up, if you short them, you'll get a pretty good sized zap and probably blow some solder off the board, which I've done. It scares the crap out of me. So I made a capacitor just discharge tool, which is some high wattage resistors, so that I can discharge those capacitors safely. There are the only ones on this board that I'm really too concerned about as far as uh, life-threatening voltages are concerned. Uh, and so this is your main voltage, and I've learned that LED strips require, or actually run on voltage. They don't require a lot of current, but they require a lot of voltage. If you have hundreds of LEDs, if you think that it takes at least half a volt to a volt to turn each one on, that adds up quite quickly, and so you get high voltage here. This is the LED driver output. This is the main connector over here, and this is the one where you short pins, and these pins here in particular. Uh, this is your STB 5 volts, and you short it with the LED backlight on and the backlight adjustment and the PSU on. So these four, you short these guys out to the 5 volts, or they all get 5 volts, and it just powers up without having it connected to the TV. Keep in mind that your LED strip, uh, this is the IC that controls the LED driver that controls the voltage and the current, constant current going to the LED strip. If the LED strip is not connected, this should not stay on for any length of time because it'll detect that it's not using the proper amount of current, and this guy will shut it down. If there's any issues with any of the components on the way to getting the high voltage to the LEDs, this guy will also detect that and shut it down. So this IC, I'll post a graphic of it as I go through this so that you can see the pinout of this guy and its model number. It's very hard to find what the model number was of this. Um, Something to keep in mind for safety aspects of this guy is that the earth, like the chassis ground, is also connected to common. So this is just their EMF suppression and that's quite new to me. I've never seen that before, but this one uses this circuit design. It's quite interesting and effective. So so this guy has a pin here, pin 18, I believe it is, that goes through this diode and powers a small transformer. And this small transformer is your gate driver path. It takes the low voltage and transmits it across so that it can be isolated from the high voltage driver side of things. And so this is the low side and high side MOSFETs here in this section. And I found that these guys were shorted, both of them. And that's not unusual. I understand that when one shorts, it blows the other one because a massive amount of current goes through it. At the same time, this fuse that looks like this this black cylinder here blew. So I replaced it with this same spec fuse and put this in there. And so I also checked the resonance capacitor downstream from this, and it tested out fine. So everything looked good. And after I had replaced this, it worked. How these guys shorted is all pins were interconnected inside the chip, inside the MOSFET. So it's quite easy to find. But it was hard for me to trace down since I'm new to this and I'm not a professional at electronic repair. So this was all discovery for me. And since it had these capacitors connected to the chassis ground, it really kind of threw me for a loop because I wasn't used to that sort of circuitry. Anyway, so then I got lucky and I managed to find out the model number of this. And so I'll put that on screen now so we can discuss that. Okay, so this is the main connector. This is the pins I've connected together to get the 5 volts across all of these pins here. Oh, not all of those, just these 4. Okay. It's nice that they have it printed on the PCB. This is an image of the LED connector. These first 4 pins here are LED strip 1 and 2, and the rest are just ground, except for this next one here. But these guys, including that big one, is all ground. I took some quick measurements to give you some sort of reference to go by. So VCC pin 1, you should be seeing, 12 volts on there. STB, which is your power on, you should be seeing, above 2.5 volts. And now what I have highlighted here is pin 9 is a capacitor that if you ground it, that gets bypassed and forces the chip to turn on because that's a timing delay for the startup of the chip, I believe. This one here is just the kind of frequencies and voltage you should see coming off of pin 18 here. I should say that these pins work in tandem across that transformer in order to in the LED driver path to fire up the gate driver. So troubleshooting this, I had the oscilloscope set up to ground on pin 3 and the probe on pin 18 because I wanted to see if it was attempting to power up the driver path. And so I had even shorted pin 9 to ground, and I was able to get a burst signal. So it'll send a burst signal out to see how the power stages are doing, and if there's any sort of anomalies, its feedback will allow it to shut it off before damages are done. But this is one way to verify that the chip is working. I'll get the oscilloscope hooked up and hopefully get you a recording or a scope shot. Okay, I have the oscilloscope hooked up with 5 volts per division and the trigger set at 3.2 volts and 800 microseconds horizontal divisions. Okay, I'm going to fire it up. Let's see if we can capture that burst. I guess it would help if I had the trigger set. Let's try this again. Here we go. There, got it. Okay, so that's about approximately 4.7 milliseconds burst. And if you see this, then you know your IC is functioning properly and the gate driver. So then you can start checking downstream components from the IC and even use this signal to trace through the downstream components to make sure that it's going through the LED driver path and through the gate driver, and hopefully everything is okay. But you'll most likely find your problems down there. All right, now that we have verified the burned components are replaced and the IC chip the LED driver is working properly, I've hooked it back up to the TV LED strips, and I should mention I had tested this before, and there was just no feedback signal, no nothing on this connector at all. So now let's see what happens. Put this to DC. Okay, let's see if we can make it so you can see it. There we go. Okay, I'm going to turn it on. Okay, let's see. So this is common. And let's see what LED strip 1 shows. 117.8 volts. And the second one, 117, going to each LED strip. So it's operational, I believe. And yes, the LED is on the TV. So I believe I've saved this Viewboard.